Hi, and we are the Einstein group number 39, and we will show you on how to get the parallel connected resistance.
Hello and good day, sir. I am John Sardinwell FIRMEZA, and once again, I was assigned to do the procedure in our lab experiment number 6. So in this lab experiment, same procedure and same simulator will be used just like in lab experiment number 4 and number 5. Specifically, the first thing that the group should do is to first discuss with the group members if what value of resistance will they be using in the lab experiment. But they should take note that the numbers should be in increasing manner from trials 1 to 3. And then after that, they should open their Canvas account and look for physics in their courses and look for their modules. And after that, they should open their modules and click the laboratory template and the link given to open the flight simulator. And after that, they should wait for the application to be fully loaded. And then once open, they will able to see lab and intro, but they should click in lab for this lab experiment. So as you can see on my screen that I've already constructed the circuit kit. So I did this for me or for me to exceed on the maximum time given to me by our group leader. So take note that we will be using in this laboratory experiment, we will be using 2 resistors, 2 voltmeters, and 2 ammeters. And then now we may start doing our lab experiment number 6. So this ammeter 1 and ammeter 2, we may call this ammeter 1 as the first ammeter and this ammeter 2 as the second ammeter. This first resistor number 1 and this resistor number 2 will you may also call this as the first resistor and the second resistor. And now let's disconnect the wait a minute, let's disconnect the first resistor to the second ammeter. And then also disconnect the wire from the left of the first ammeter. And then we just need to drag the first ammeter and the first resistor and adjust it in a on a downward position, just like this. And then also adjust the wire that has been disconnected. And then this also disconnect the wire below near the switch and the wire where the second ammeter and the second resistor is. And then adjust the wire. And then let's start adding more wires for us to for these materials to be connected all in all. I'm just gonna go this connecting it all and adding more wires. Give me a second. So this should how it looks like. And then we may now change the value of the resistors. For example, here in resistor number 1, we may change it as um, 15 ohms, and then the resistor number 2 we may change it as for example we have 30 ohms. And then also here in the battery we will also change it as for example we have 20 volts. And now we may now drag the 2 voltmeters and attach its terminals on the resistor 1 and 2. So the orange one should be on top and the black one should be below. And now, let's close the switch and we may now start recording the data on our tables. And after this, we should reopen the switch, like just like that, and then transfer the terminals of one of the voltmeters on the ammeter beside the switch for us to determine the total current of this activity. Like that. And now let's close the switch again and record the data on our tables. So thank you for listening, and this ends our procedure for lab experiment number 6.
PET simulator. Circuit construction kit DC is a circuits with batteries, resistors, ideal and non-ohmic light bulbs, fuses, and switches that determine if everyday objects are conductors or insulators, and take measurements with an ammeter and a voltmeter. It also gives you the circuit as a schematic diagram or reach to a lifelike view. We also define voltage, which is difference in charge between 2 points. Current is the rate at which charge is flowing, and resistance is a material's tendency to resist the flow of charge. In order for us to verify the principles that govern resistance, which are connected in parallel circuit, we use PET simulator. Circuit construction kit DC.
In this laboratory experiment, we were tasked to answer the main objective of this experiment, which is to verify the principles that govern resistance which are connected in parallel. We have learned that the resistors are said to be connected together in parallel when both of their terminals are respectively connected to each terminal of the other resistor or resistors. In a parallel resistor network, the circuit current can take more than one path as there are multiple paths for the current. Since there are multiple paths for the supply current to flow through, the current may not be the same throughout all the branches in the parallel network. By conducting this study, we were able to define the following terms. So we define the parallel circuit as one, where the resistors are connected to the same 2 points or nodes, and is identified by the fact that it has more than one current path connected to the common voltage source.
Observations. Resistors are said to be connected together in parallel when both of their terminals are respectively connected to each terminal of other resistor or resistors. Resistors are in parallel when each resistor is connected directly to the voltage source by connecting wires having negligible resistance. Each resistor thus has the full voltage of the source applied to it. Based on our table and gathered data, we were able to come up with our observation. The table shows that voltage is the same across each component of the parallel circuit. Resistance 1 and resistance 2 have values that are increasing and is inversely proportional to its values in the total resistance, which decreased from 0.46 ohms to 0.11 ohms, and the reduced values of the currents from current 1 and current 2 throughout the 3 trials are directly proportional to its total current that come from 4.12 amperes to 0.98 amperes. Resistors in parallel have a common voltage across them, and this is true for all parallel connective elements.
The procedure for parallel connected resistances is almost similar to the procedure for series connected resistances. Based on our table and graph, we were able to attain 3 analyses, which are divided into 3 different parts: resistor, current, and voltage values. First, based on the assigned resistor values, it is seen to be in ascending order throughout the trials. However, the resulting RT value is apparently decreasing but in minor decimal differences. The fact that the values decrease show that the assigned values and its results from the given formula are inversely proportional, as seen in the graph. Second, as for the values of the current, the results are based to be from the ammeters from the FET simulator. The given values are all seen to be in decreasing order as represented by all three downward slope lines. Therefore, I1, I2, and the resulting current from all three trials are directly proportional to each other. Also regarding the fact that the lines are seen to closely converge, so the probability of the lines of value converging if trials are continued further is possible. And lastly, all the voltage values of the specific value 9 to the trials, concluding that the said value is constant, explaining the straight-only line shown in the graph, which is actually three straight lines overlapping each other in the value 9.
I'm Andre Relano and I was assigned to do the task in conclusion. The main objective of this laboratory experiment is to verify the principles that govern resistance, which are connected in parallel, and through conducting this experiment, we were able to verify the principles that govern the resistance. Based on our collected data, charts, conversations, observations, and evaluation in a parallel circuit, we conclude that since there are multiple paths of the supply current to flow through, the current may not be the same through all the branches in the parallel network. However, the voltage drops across all of the resistors in a parallel resistive network is the same. We also justify that resistors in parallel have a common voltage across them, and this is true for all parallel connected elements. Thank you.
So, through conducting this last laboratory experiment, we were able to answer the main objective of this activity, which is to verify the principles that governs resistances which are parallel connected using the FET simulator. So, based on our graph and gathered data, we were able to attain our discussions, observations, analysis, and conclusion. In our discussion, we discuss what we have learned and we give definition for some terms which are presented by our presenter, and through our table we're able to come up with our observations, and for our analysis we presented three of it, and we were able to make our own graph and give our interpretation. And lastly, for our conclusion, we concluded that resistors in parallel connection have a common voltage across them, and this is true for all parallel connected elements. We also further explain our statements. So I am DIESTRO, the validator of this group, and thank you for listening and have a good day. Thank you.